Welcome, ladies and gentlemen, to Pawn's How to Do RPG Advanced. Get a lot of tutorials that get you through your movement systems. They don't really cover the diagonals, or they ignore it, or they skip it. We're going to cover the diagonals, and we're going to add a running feature to our character's movement. So you're going to be able to walk and sprint with the press of a button. You're going to up, down, left, and right, and diagonally without the movements. So, first thing we're going to do, we're going to create a sprite. I'm going to go 64 by 64. Open it on up, and I am going to draw me the world's most fantabulous. Go with this. Yeah, sure. We're going to draw a head. We're going to draw a stick figure. Right? Now, you could just use a plain white thing. I'm going to make a stick figure. Right? This is just a placeholder. Better than that, I'm going to make it green. Now, blue. Blue seems like something that should represent the player. Okay? Hold on. We're not putting in artwork yet. We're going to call this SPR, which is our abbreviation for sprite. Some might just use the letter S. SPR, player, capital T, for temp. Okay, this is going to be our temporary player. I am not going to import any sprites into this at all. At all. This will be it forever. Go ahead, put this in the bottom center. It's going to move our X and Y origin down to here. Move that manually. Wherever you want. Let's say your character's not fully on the bottom and you put it up. It's generally a good idea to put it between their feet. Alright? And then we're going to move to our collision mask. And instead of full, we're going to go down to manual. And I only want if roughly his feet collide with something. So that's where his feet are. Right? If his feet collide with something, now this one is a little farther in. One is, yeah, right. If his feet collide with something. Okay, just his feet. Now, we've already gone way more in depth than most things. So, we're going to go ahead and we're going to add one more sprite. Create sprite. Right. This time, I'm going to resize this. Okay, and I'm going to resize it like 16 by 16 instead of 64 by 16. Okay. Bunk. Why? Now, this what this is. This is the resize. Brings up all this. Already had a picture. Aspect ratio means I'm going to keep it the same. Okay. We're going to leave at the top left. Okay. Now you can hit edit image here. You can double click the frame. All I'm going to do is take red. Paint bucket. I'm going to click this red. I'm going to make it about half alpha value. Boom. I'm going to paint it. So it's slightly see-through red. And it's significantly smaller than the player. This is going to be SPR collision. Okay. So now we have temporary player, SPR collision. Right? Already started with a room. And the backgrounds. Yours probably starts with no background. Or a black color, something like that. Right? I'm going to go ahead and set it to say a nice green. Move in here, it's desaturate a little. Nice green. Say our grass would be. Room is set up, and then we're going to this here. Right click, rename, press F2, RM for room, main. So that is our main room. But we have no objects to put into this. Go ahead and create an object. Create the collision objects. So OBJ collision. And we're going to call this one a parent. Okay? It renames up there. You could also rename it here. We're going to give this the sprite or create collision 60 by 60 mask. Okay? That is all we're going to do with this. That's it. Now we're going to create another object. Create object. This is going to be our player. OBJ player. And again, this is going to say temp. The reason why it's going to... yeah, we'll just call it player. The sprite is temp. So we're just going to use the sprite from... okay. Now let's make the magic happen. Add a create event. Now we said we're going to go ahead and get rid of all this extra space and leave this word description. Alright, so we're going to describe what's going to happen here. Okie dokie. And the best description really of what we have is this is our main step. Or, no, not main step. This is our starting variables. Okay? And we're going to set our WSPD, which is a thing that I've created for walking speed, equal to 1. Our SPD, which is our running speed, equal to 2. Okay? So, our walking speed will be multiplied by 1, so it'll equal whatever. And our running speed will be multiplied by 2, so double, twice as fast. Okie dokie? Then you'll be able to modify this later on. So this way, if you decide you want to change your speeds for whatever reason, it'll change the speeds. Now, our step event. All of that extra space, leave the word description. Okay? This is going to be our main step event. So this is where all the things are going to happen, right? And I also like to put in big old notes so I know exactly where I am. Main step events. Alright. So this will rename this up here. So you see I got renamed to starting variables, main step event. This will let me know this is where my main events are happening. And in here I'm going to create a region by hashtag region. Okay? And we're going to call this movement and collisions. Here, we're going to hashtag end region. And all that's going to do is whenever code we type in here, right, we'll be able to minimize it later on, or explode it later on, so that we only see the code we want to see. This is really helpful for when your code gets really super long. I'm setting you up to have a fully functional game skeleton so that you can make your game out of it. Alright, now the first thing we need to do is we're going to we're going to check for inputs. And yes, I do make lots of really... I'm going to create our temporary variable. So VAR is a temporary variable. This is a variable that will only be used here. VAR key R. Right? And we're going to keyboard check for a key. Now, we're going to do VK underscore right. Okay, so that's that right key. And or, which is 2 lines, or the word or, 2 lines. We're going to keyboard check for a specific key. So ORD, quotation marks. In here, key. Right? So, we're going to look for the right arrow key, or keyboard check for the keyboard D key. Right? What is up with you? Expected. Yep. Expect the thing. Okay, well, let's check this. Always check red squigglies. It means something's wrong. Oh, yes. Forgot. That's wrapped in brackets. Bracket, bracket. Bracket to the outside. bracket to the bracket, 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 bracket. Okay. All right, so that is going to be our right and our keyboard check for D. So it's going to look for or. Okay, you could use the word or here. It really helped you. It helps you visualize it. Use or. Okay? But just know that anytime you see these two straight up and down lines, okay, which is going to be, if you have an American keyboard, just above the enter button, you'll have the backslash and a straight up and down line. Okay? Not sure where on the keyboard that is. That's going to be our keyboard right. Now we're going to make a few more. Right, so I have 5 of them. Paul, there are only 4 directions. I'm getting there. We're going to check for up. Right? Check for left. We're going to check for down. And this last one we're going to rename to Am Run. Okay, which is my keyboard for Am I Running? Alright, so obviously the keyboard for up is W. The keyboard for left is A. Keyboard for down is S. And the keyboard for Am Run, well, we're not going to give it a keyboard. Keyboard check. Okay. Now our right key is VK right, our up key, VK underscore up. Our left key is VK underscore left. Our down key is VK underscore down. And our am check, I want this to be VK underscore shift. Okay, so if we're running, that's our buttons. So we've inputs from the player. Always add notes. Like, I can't emphasize, if you want to make a full game, how important notes are, because I know we keep saying you can make a game in like 30 minutes, an hour, or whatever. Yes, you can. But by the time you start adding polish in screens and start screens and menus and inventory systems, and you may not look at this code for another month or 2 months or 6 months or 1 year. And by then, you will have forgotten everything you are currently thinking about. Leaving yourself a note. Very, very, very important. Also, it's very important for, let's say your game really does take off, and you eventually need a second dev to help you. They need to know what you were thinking at the time. So, leaving yourself a note. So, next we're going to do our variables. Variables for movement. Alright, and so we're going to add our VAR. So, our temporary variable, we're going to call this move X. We're going to equal it to 0. And our temporary variable for move Y, we're going to set that equal to 0. You guys keep asking why I'm pausing when I'm doing these things. I'm giving people the chance to actually type with me. You don't know what you're typing, so you're not going to type it nearly. Yes, I am pausing slightly for the new. Alright. Next, after we've set those variables, we are going to figure out what direction we are moving. Okay, so direction, we are moving. Alright. Now, I'm going to leave a note here, which will all make sense in a moment. Our outputs will equal -1, 0, or 1. Okay? So, how do we do that? So we're going to make our move X, which is the variable that we created earlier. We're going to create that equal to our our key right minus our key left. So what this is going to do, so if key right, so when you press it in, it's going to equal true. So it's going to equal the number 1 for true, 0 for false. So if you're pressing it, we have 1. If you're not pressing left, then left will equal 0. So 1 minus 0 equals 1. But if we're not pressing key right, it's going to equal 0. Are pressing key left, it's going to equal 1. 0 minus 1 equals -1. So it'll return a negative value if we're moving left, and a positive value if we're moving right. So which direction we're trying to move. Now we're going to call our move y equal to our key down, brain, down, Cujo, minus key up. And again, so it's going to give us a -1 or a 1. 1 means we are moving downwards, because the x and y moves opposite from what you learned in high school. On this, imagine, so x, remember in high school you learned you had your x, y went up and down, and your x, y. So positive was in this direction. Well, up here we're starting with the x and y starts in the top right, or top left, and positive x moves to the right, negative moves to the left, positive y moves down, and negative y moves. Either way, it all makes sense once you start seeing it. Okay, so all that did was return a -1, a 0, or a 1. Right? Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to determine our speed. All right. Oh, so this is if moving straight. So we're not trying to move diagonally. Okay, so if we're moving straight, our variable that we're going to invent right now, our regular speed, okay, going to be equal 0 currently, right? And this is the variable if moving diagonally. Go ahead and throw the word variable. Good note keeping is extremely important. Okay. And we're going to call this, reg speed. Right? Yeah, reg speed sounds good. And we're going to call this one variable dia for diagonal, spd for speed. We're going to currently set it to 0. And that's all good and dandy. All we've done is made a variable. We haven't done anything. Now, test if we are running or not. Okay, so it's very important that we do this. We need to check for an input. We check for the input, we could just move the player, right? Which, yep, it'll move. Oh, cool. But then, when we add collisions, if we add the collisions after that, right, it'll move, and then check for a collision. But it's already moved, so it could overlap and then collide, and then you'll run into some serious problems. So you want to check if moving. Or if the player is trying to do something. That's all this is. Right? Then you want to check if what direction the player is attempting to move. So now you've figured out where we're moving. Then you want to check, all right, are we running? Are we not running? So now we're going to check the speed of the movement. And if we're moving diagonally, remember how diagonals move slightly faster? So we're going to handicap the diagonals so that they move the same speed as a straight line. And then we're going to check for colliding. Then we move the player. It is very important that you do all in this process. Like I said, this is going to be a slightly advanced tutorial. If you're new, hang on there. If you're not new, you probably love me for that. Alright, so we're testing if we are running or not. Okay? So we've determined the direction. Now we're going to determine the speed. Okay. Determine speed. Because our value for speed is different. Oh, not determined. No, running or not. Running or not. I'm sorry. Running or not. So now we're determining our speed by if not running, not am run, which is the variable we invented earlier. The exclamation point equals not. You could type in, you could technically say not equals run, or am run, or not am run. Not run. It's so bad that I don't even know how to say that, but doing it like this, the exclamation mark, makes all the coding so much easier, and it makes it much easier to read, easier for you to read it. So if I am not running, okay, if I am not running, so if the player is not pressing the shift key, not running, so return a value 0. Right? We're going to set our regular speed equal to our walking speed. Right? Did I create a different variable? Nope. Okay, fine. Yeah, sure. Then we're going to set our dia speed, which is our diagonal speed, equal to our walking speed. Now here's where it's going to get funky. You need to type this number in very accurately, 0.707. I'm going to take back a fraction of our current speed. That's how fast we will be moving if we are not trying to run. Else, if I am running, so at this point, so if it only has two options, right? We either are trying to run or we else are not. So we started with not running. Okay. Now, if this is not true, so that means I am running. That means we are pressing the shift key. Now, you could put if am run. I'm just going to use an else because I know it's the opposite of our last statement, right? Else is only really good if we have two options. Our regular speed now equals running speed, that variable we set up earlier. Our dia speed is equal to our running speed multiplied, so star, by that 0.707. Okay? Now, why am I doing it like this? Pawn, you could turn it into a vector, and then we could vector the speed. And you are absolutely correct, Mr. Knows more than the people that I'm teaching. Could absolutely do that, but we're not. We're going to get an approximation that is so close, no one will really, truly grasp it. You won't really see much, if any, of a difference, unless we're talking about speeds that are greater than, like, you know, you're talking car movement speeds, really super fast. Okay, then we need to really start vectoring. But these guys are going to move at like 1 pixel, 2 pixel, 3, 4, 5 is super fast, right? So we're not going to be moving too terribly fast. So this is more than perfect and simplified for a like an RPG. Okay, so this is one of the better codes you're probably going to use for an RPG. Okay, so we've determined the speed. Now we need to run a collisions check. Collision check. Alright, now first things first, we're going to check for X collisions. Now, this is where I'm going to tell you to hang on, because what I'm about to do is going to be a little bit more in-depth than what everyone else is going to do. Okay? So, we're going to start with if move X, right, does not equal 0. And that's all of our collision for X is going to be in here. So, this is going to make it so that your code later on, when you have lots and lots and lots of code, it's running constantly, which is the more code you have, the more it's going to slow down your game. If you are not trying to move, so if X equals -1 or move X equals +1, you are attempting to move. You've put in a keyboard input. If it equals 0, that means you are either inputting both, or you are not inputting at all. You are not trying to move, so do not run this code and save us the tiniest bit of memory. Now, all this, people will be like, well, it's really not worth saving that much memory. It is when you multiply this by thousands of instances. So it will set you up for a much better game. So if place meeting, I recommend typing out the whole thing while you're first learning. Make sure we put in our curly bracket now. Place meeting now. Place meeting needs an X and a Y coordinate. So X, comma, Y, comma, and this is going to be our OBJ collision parent, right? Now, here's where the magic is. We're going to go into X, okay? We're going to add, in brackets, a set of brackets here, our move X. Okay? We're going to multiply that by our running speed. Very important. So it's checking the maximum distance away. Okay? So this is, we are moving, and the maximum distance we can move away. Right? Now we're going to repeat. Repeat. I can. Okay, we're going to do an ABS. Okay. Of move X. Okay. Now, pawn, what is this nonsense? Okay, coding is math, and more math. Okay, the absolute, we're going to repeat the absolute number of X. Okay? So, if X is 1, repeat. If X still equals 1, repeat again. Repeat again. Repeat again. Repeat again. Okay? And it's going to keep going until X is no longer 1. Okay? Now, inside our brackets here, if we're going to do just like before, a not, which is that exclamation point, place meeting. Okay? Remember, in here we need an X, comma, Y, comma, the object we're talking about, so our OBJ collision parent. Alright? Make close off our bracket now. Now, here's where the math is going to come in. So, our X plus our sign. Now, sign just returns both values. So, if X equals 0, the sign of 0 is 0. If X equals 1, the sign of 1 is negative 1. So if it's a positive, make it a negative. If it's a negative, make it a positive, and check both. Okay, so it's checking 1 and negative. It's checking in both directions. Okay? So we're checking for our sign of move X. Here we'll put more brackets. Move collision parent. Okay? Where is your problem? Unexpected at this time. Okay, X. Expected. Oh, yeah. Don't expect that. Hold on. All right, bracket. Bracket, 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 bracket. Bracket, bracket. Missing a bracket somewhere. Alright, so we'll start with welcome to bracket check. The bracket is expected. I'm pretty sure that's not right. Okay. Open bracket. Close bracket. Bracket close. Bracket 2. Bracket. 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 Our missing bracket right here. Okay, move x is bracketed. The whole statement is bracketed. Move x is bracketed. Repeat ABS is bracketed. If has a bracket. Too many. If not place meeting. X plus the sign of comma 1. A collision. What is making you mad? Welcome to coding, by the way. Always stop whenever the game gets mad at you. If not, place meeting. 3 arguments, but 1 are provided. I provided 3 arguments. Oh, why did you close? Oh. Yep. It was a bracket problem. It's always a bracket problem. Alright, and then we 1 out, 2 out, 3 out, 4 out, 1 in, 2 in, 3 in. That bracket. That full. Let's start typing in here. We'll figure out what that mad bracket wants. Okay, so if not place meeting, x plus sign of move x, y, obj collision. Okay. So we're going to make our x plus equal our sign of move x. Okay, already closed off this bracket. Okay, now we're going to check for, is it a pixel away? Is there something that we can collide with at the maximum distance away? But it's not colliding with us yet. Move us 1 pixel, run it again. Repeat. Is it still within the maximum distance? Yes. Is it within 1 pixel? No. Move us 1 pixel. Check again. That's all it's doing. So else, so if all of a sudden something becomes within 1 pixel, right? We are going to break out of this loop. Okay, so now it could break on its own. Okay. No enclosing loop from which. Oh, yep. I'm breaking in the wrong. I'm not. Calm down. ABS. Pretty good. Down here, else. Else. Here we go. Yep, I broke in the wrong point. Break. Welcome to coding. No loop to break out of. Okay. Let's figure it out. Alright, here's our repeat. Where is your closing bracket? Here. Else. Break. No loop, which to break. Should be on this if statement. I'm gonna put it here. Else. Break. Yeah, that's where it's going. It's mad at me, and it's saying it can't break, but there we are in a repeat. Now, granted, it can break itself, but... Alright, so now we're going to come down here to this second line. This second line comes all the way from this top line. Okay? That is where we're going to put our move x equals to 0. There's a lot of it getting mad at us. Expected. We are missing something. Open. Open. Big close. Open. Close. What? You are mad at me for something. We are missing a bracket. Welcome to coding. Brackets are like my nightmare. Bracket, bracket. 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 Bracket, bracket. Bracket, bracket. Bracket. Boom. There we go. Fixed it all. See, it was all just a thing in the wrong place. Knowing where your brackets are is super important. I'm sorry, but this happens. Coding. Okay, I'm going to get rid of that end because I'm not ending. Whew. Okay, so the re-breakdown for exactly what has happened here. If movement does not equal 0, we are trying to move in the x plane. If place meeting x, our current x position, plus our move x, so 1 or -1, times our running speed, which is the maximum speed at which we can move, is there a collision with this parent collision object? If so, repeat this next piece until we are no longer colliding. So we're going to place, if not place meeting of the x plus sign of move x, right? So if not meeting, let's say it's checking for 10, right? It's going to return 1. Sign will always equal 1 or -1. So it is going to equal 1, -1. It's going to check for both. Okay? So if not, our sign of move x, so let's say, whatever, becomes 10, there is a colliding, check 1. Okay? If there's no object within 1 pixel, move us 1 pixel. Right? And keep doing that until the very thing next to us is the parent, in which case we're going to break out of this loop. And we're going to set our movement to 0, no longer move. This will create a pixel-perfect collision. Right, now we're going to do, copy all that. And now we're going to check for our Y collisions. Now, some of you might be like, Pawn, well, what the heck is going on here? And it's really hard to follow. Tracking. Welcome to coding. Mistakes happen. It happens to the best of us. Alright? So, for our Y, go those just together. Our move Y is not equal to 0. Not moving in the Y plane. Our X, well, we're not testing for X anymore. So we're going to remove that from X. We're going to put it on Y. We're going to change this to our move Y speed times our running speed. So our maximum possible Y movement is their apparent. So repeat your absolute value of move Y. So it's not even going to fractionally. It's going to give an absolute value of Y. It's going to keep repeating until breaks or Y becomes 0. Because what absolute means, like it's going to keep repeating 1. And as long as it sees the number 1, it's going to keep repeating. Okay. So we're going to check if not place meeting. Right, we're not checking for X, checking for Y. So copy that, paste that in. Y plus the sign of move Y. So within 1 pixel of Y, it'll be parent. We're going to make our Y movement plus equals sign of Y. So even if move Y equals to 10, going to assign it, which makes it equal. Okay, keep doing that. And then that code should run by itself, but I give it a break just in case Gamemaker skips a frame and freaks out. Now it can break out. We're good. In which case, our move Y should then be 0. So that is our collision check with pixel perfect checking. And then in here, I'm going to go ahead and give myself another title. Yep. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't ask me why I do that. Now we're going to apply the movement. Alright, so if we're going to start with move X does not equal 0. and, which is the and symbol twice. Right? Or the and symbol twice. Move y does not, exclamation, equal 0. So the first thing I'm checking is wrapped up in this statement. If we are trying to move left or right, and we are trying to move up or down, so if we're pressing both a left and an up key, or let's say the right and the up key, or left and the down key, or right and the down key, we are trying to move diagonally. It's not X or Y. We are moving X and a Y. They are both greater or less than 0. We are attempting to move in both directions at the same time. We have determined we are moving diagonally. So, if moving diagonally, so our X is going to be plus equals move X. Now, we're going to multiply that times a dia speed. So, dia speed, so our move X, 0, 1, multiplied diagonally. Our Y plus equals our move Y multiplied by dia speed. Alright. Whew. Pretty simple. Straightforward. Now, if else, so any other combination of controls, right? We're going to, if moving straight, because we're either moving straight or diagonally. So we've checked the diagonals first. Now we're going to check the straight movements. Our X plus equals the reg speed. Move X. What am I doing, Pawn? Move X. Our regular speed. Right, so that's our regular movement. And our Y plus equals our move Y multiplied by our regular speed. Alright, so what this is doing is if we're trying to move diagonally, take how fast we're supposed to move and make it the diagonal speed we set up earlier, is multiplied by that 0.707, so it's going to make it less distance than as before. So our diagonals will become the same distance covered as if we were to move a regular direction. So diagonals will no longer be faster than before. Right? Whew. So, we applied the movement. Let's go over this whole thing again, really quickly. Just a little bit. It's going to make it really hard to read on your end. I apologize. But you have it written in front of you. Goodness. We wrote a good bit of code here. Alright. By the way, remember that region thing we put in the beginning? Everything in there, bonk, becomes that big. So for typing later on, it makes life easy. Okay. So up here, we checked for our inputs. Right? Then we made our variables for the movement. Checked which direction the player wants to move. So, the player has asked to move in a direction. Remember, the player is asking to move. Okay? Then we are determining whether our player, our variables for if our player is moving in a regular direction or moving diagonally. Now, then we check if the player is running command. Okay, and then we're setting our speeds to the running command. If they're not running, we're setting the speed to the walking speed. So regular speed becomes walking. The diagonal speed, walking diagonally. Regular speed becomes running. So we've set the speed at which the player will move. Right? And we checked, is there anything on the X and Y in the sign area within the colliding, and then is it signed within the colliding? So if let's say our moving speed is 10, there's an object within 10 pixels of us. Sign Is it within 1? No. Move 1 pixel. Check again. It's still within 10. Move 1. Move 1 until we've collided with the object pixel perfectly, then move 0. Okay? So, it won't let us move past that. Our code only runs if the player is trying to move, saving us there. Check for our Y collisions, which is the same thing as before. Our Y speed, let's say it's within 10. Okay, there is an object. Move 1 pixel. Our sign. Keep going. Sign, 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 sign until the 0. Then stop moving. Then we applied our movement directions. So if we are moving diagonally, move our X and Y at the speed of diagonal speed. Else, we're trying to move regularly, move our speed at the speed of regular speed. Now pawn. All of that is big, and then that region and region we put in the beginning. Let's go back to normal size so we can read things again. Oh, test it. I'll put our object room on the instances layer. Okay. Background was set to a nice color green. You can go down to color. I set it to a nice green that's kind of similar. Okay. Our blue object player temporary sprite. We're going to put our collision parent in. Yep, we are on the background layer. We need to make sure we are in instances. Our background is super small. I kind of want to stretch this out. Yeah, see, it's not perfect pixel collision with the frame. You can come up here and set this grid, do whatever you want. But I am very much smaller than my grid on purpose. Stretch it out. The reason why I'm smaller than my grid is want to, in case we get a, let's say a funny size thing later, I can be more accurate. Like, see, there's a gap in there. Teeny tiny, I could put that in there. Punk. Then, just to check that we have pixel perfect collisions, that's 64. But that's 32. Okay. That's 4. By 60 square. So we should not be able to fit in there if it's not pixel perfect. But our feet, remember we had our masker and our feet, so we're only really checking this tiny little, which if I'm not mistaken, per player might be how to figure out how big your mask is. Calculator. Calculator. Alright, our right is 46, minus our left of 28 pixels wide. Okay. 28 pixel collision. Alright, whatever. Well, we set up our room however we want. Punk. Now we're going to run it. Remember, only our feet should collide. Run. Feet collide. Okay. Pixel perfect. I can't weasel my feet in there. I can't get stuck. Right? Even if it's not perfectly on the same grid. We change speeds. Our speed stays the same even when moving diagonally. All works in all directions. But you'll notice the player doesn't appear on top of this. So we're going to quickly fix our depth. And then we will be done with this particular episode. So let us go ahead, close out this main room, create an object, create. This is going to be our OBJ controller object. So this is the thing that is going to run all of the main functions for the entire game. It will have no sprite. Put in our create event, our description. This is our start of game variables, okay? And we are going to say with, in brackets, all instances, depth is going to equal the negative of our B box bottom. Okay, what a B box is the bounding box, the bottom of your bounding box, the very lowest point. Right? We're going to create a negative of the B box so that everything has a set number. We're going to then copy just this little piece, not the all, just this little bit. All right, and we're going to go into our object player. Movement and collisions. And we stretched it out really big, so bring this back down again. We're going to go all the way down to the bottom. On here, add one last note. Fix depth. Bonk. That's it. Now, when we run the game, you can have the illusion of being able to walk in front of things. Right? So that our player appears in front. Okay. I want to check that we're going to create object, separate object, call this OBJ wall. OBJ. Sure, why not? Create a new spray. Now we're going to leave this one as 6464 because remember our collision checker is only by 60. Okay, we'll edit this. We're going to draw a box. Right click to draw a box. I'm going to draw another box. That all seems right. Okay. Top of the box. Okay. We're going to fill in the box with red, darker red. Oh, there's our box. Okay. SPR. Collision. Checker. We're going to get rid of this later. This is just to check currently as a wall. Wall. Collision checker. Right. No code needed. We're going to go into the mask manually. We're going to move this mask down. Remember, we want the player. So imagine where the base of the item. Base of the item is somewhere about here. So if the player were to walk behind it, the player would be behind it here, in front of it here. So now our player, just to check that, our wall, check our collision parents. We're going to add a children with this plus button. We're going to add this wall is a child of the collision. So there's no code in that wall whatsoever. But every time our player refers to this collision parent, it will check for that wall. Room. Add some of these walls. Right. Sure. Add them like that. Run it. And now we should be able to run over there or in front of the wall. Oh, you know what we forgot to do in our room? We forgot to put our controller object where it's got no sprite. Now, run in. Player front of the wall. Player behind the wall. And we have the illusion of 3 dimensions. Alright. That is the basic movements for your RPG and the tutorial. If you are a beginner and you are struggle bussing with this because I probably went too fast or real life happened where my code was not perfect. I literally made this code fly with you in the best way that I could think to do at the beginning. Notice some errors happened in the middle of me coding. This will happen to you. It will happen. You will find a bug. You will forget a bracket. Mistype something. That is the reality of coding. It will happen. So if you have careful notes and pay attention to little red squigglies. It means something. Something is wrong. Okay? Better to check immediately upon the squiggles appearing than to finish all of the code and then go, oh my god, there's a squiggle, something has gone wrong. Because if in here, alright, we have that code is ginormous, right? Huge code, right? At the end you see a squiggle on this very last one, but your missing bracket is like up here somewhere. You won't know. You won't know where the missing bracket is. Squiggly, it expects a bracket here. Because it's still trying to read up here. Let's say I got rid of this bracket right here, right? Forgot to type that in for some reason. Right? Now it's going to... It's still trying to read it, 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 still trying to read it. And it's not going to run any of this because it's looking for where this ends. Right? God forbid you missed a bracket like up here, like on the end of a big statement. Now everything turns red. Because it is now that bracket everywhere. Not everywhere within this if. So, yes, that does happen. Be very, very careful. Next time, I know we have this temporary thing. What we're going to end up doing next time is instead of importing sprites onto the player, we're going to import sprites into the game, and then we're going to have the game, we're going to say, let's say, 2 or 3 different characters. We'll let the game choose which character it wants to use. So let's say a character with brown hair, black hair. So we'll have options set up right off the rip of things that can happen to the player. Let's say a player with a shield, a player with a sword, a player with armor, a player without armor, a player that, say, red shirt, a blue shirt, black pants, white pants, whatever. You'll have the ability, by the time you're done with my next lecture, to have that selection system and a way to code it in so that you will be able to quickly make NPCs. So instead of having a different sprite for every NPC, we'll have one sprite sheet to hold all the different possible things, overlap them together, so you can create with code what each person looks like without importing a new sprites. Now, the reason why you do this is, yeah, let's say I import 2 bodies, male and female. And then 2 sets of shirts, blue and white. Right? So there is, you could have the dude without a shirt, dude with a shirt, dude with a white shirt, dude with a blue shirt, chick with a shirt, chick without a shirt, chick with a blue shirt, chick with a white shirt. Okay? I just realized what I said, and don't quote me on that one. That is not an intended feature. But you have 2 choices, man, female. 3 choices with option 1, with option 2. Then the female without, with option 1, with option 2. So there are 6 choices of possible outcomes, but you have only uploaded 4 sets of sprites. Hopefully that makes plenty of sense. And so you'll be able to put in less sprites to make more possible outcomes. So the player can then choose what they want, and the player can then, when you type in, say, an NPC, instead of downloading a whole new NPC and a whole new set of things and a whole new set of artwork, just be able to type in, I want this NPC to be a female with a blue shirt and white pants. Boom, you'll be done. And the game will generate that NPC. And that is what we were going to do on the next episode. For now, as the end of every episode, everybody zooms to the end. I know you do. Player can walk. Player moves diagonally. Player can sprint. Player collides. And the player has the appearance of 3D with some... Alright. Hey. Take it easy.